Hello guys, welcome back to class. In this session, we'll continue with remaining topics. In this, we'll start with the selecting rows and columns. Every row has a index, right? Every row has index. Every column also has index. Every row has a label. Every column has a label. Even we can change the row labeling also, but indexing we have for all, right? So how to use them to select? What is indexing and slicing? Most important always. What is indexing, guys? Indexing means accessing a specific row or a specific column. You want a fourth row, then index is 3. Go to particular row, access it. You want second column. Second column is index is 1. So accessing specific row or column is an indexing. Slicing means selecting a range of rows or columns. Slicing means I want from this row to this row, or I want from this column to this column. There's a slicing. So we have 3 options to do this. Quick access, we can use our regular syntax. Parentheses we can use. And there are 2 important methods, LOC and iloc. Location and index location. LOC is a short form of location. And iloc. Because every row and column has a label, right? Every row and column has a label and also have an index. LOC can be used for a label-based selection, index-based selection, or a position-based selection. How to do this? 3 options. You can select a particular column in 3 ways indirectly. Am I right? Every column can be selected in 3 ways using basic syntax of square brackets or iloc method, lock or iloc methods. Okay. I have a same sample database, same data frame I am taking. We have a 6 columns and around 8 records. This is a data frame available. Student ID 1 to 108. Ages are various. Some cities, some fees, etc. etc. Fine. First, start with the selecting columns. If you want a single column, how to make this, guys? df of name. df of name. You see the syntax here. From your data, when I say df directly, when you print df, what is happening? When you print df, here you see df means it is taking, when I say df, it is taking all the columns and all the rows. All the columns and all the rows. I am telling, I don't want all the columns. I want from df, please give me only name column. You are selecting single column, right? Single column is always it comes as a series. One column, all the values internally it will show as series object. Same single column, if you write as a list, it will come as a data frame. See the difference. In this, I am writing a list. City. Do you find a difference here? Single column directly if you write, you will get as a series. But if you write as a list internally, you will get as a return type as data frame. You are getting another data frame object. In the data frame, there is one column and all the rows. Multiple columns you want? Yes, always you follow this multiple columns, return type always data frame, right? So df of, in that df, your square bracket is a part of syntax. Now, what do you want? You want 2 columns. Again, a list you specify internally. You write your first column, comma, second column. Syntax is clear, guys? You want 3 columns. Again, in the list, you write the 3 columns. Top bracket is for a accessing. Inside that, a list with column 1, column 2, column 3. You can keep a single quote, a double quote. That anyway, we know that both represent same in Python, right? Accessing single column, multiple columns, clear? Let's see the output. So I'm accessing only single column, guys. Names. Next, accessing single column. City. Accessing multiple columns. Written type is data frame. Mini data frame we got. Accessing 3 columns. Specific columns, whatever you want, you can see this. Clear? Next. Selecting rows. Selecting columns, we understand. Selecting rows. Selecting rows, you can do with iloc and a loc also. First with the iloc, with index based. Single row. You want a single row. df dot iloc of, suppose you want first index 1. So index 1 for a row 2, right? Second row. Second row will, second row, all the columns, guys. Previously picking the columns, but this is only row selection I am doing. One row, but all the columns will come. You can also specify df dot iloc of, if multiple rows you want, again I specify the list. I specified here as 1, 3, 6, something like this. This list of rows you can specify 1, 3, 6. Row slicing. Row slicing, you can say that I want from 2 to 7. iloc. Slicing means always you will have a colon. Remember that. df dot iloc of 2:7. So here in this, what is the start value? Tell me. Start equals to 2. Stop equals to 7. Step equals to 1. But always it won't go to stop, right? It will go to before to stop. 2 to 6. Row selection is clear using iloc method. It's all simple only. You have to practice, more practice. So first is second row. When you say single row, it is showing in a vertical way like this, single row generally, because we'll have thousands of rows in the real world data. We won't select single row. So next I am taking 1, 3, 6, 3 rows. Yes. 2 to 6. Row selection is clear. Okay. Next. Selecting rows using LOC, lock method. Lock method, currently, lock means I told a label, right? For a row, any label is there, df dot loc of, you have to specify the row label. Row label, we didn't explicitly name the label as of now. We didn't explicitly name the label. So this index only will be considered as a label. Am I right? This index only will be considered as a label. This index only will be considered as a label. So you write the 2 here is considered as label. 2 is considered as label. Give me the row with the label 2. Nothing but index 2 only. But as we don't have an explicit row name. Next, multiple means df dot. So I said 2. df dot lock of 257. Seventh row is there in this. Yeah, it is there. Right? And row slicing with the LOC, lock method. 2 to 7. And here is the difference, guys. When you say the row label, it will give all 2 to 7, it will give, guys. 2 to 7 it will give, because this is not index. In the index only, it will take before that. You are asking, give me the row with the label 2, label 3, label 4, label 5, label 6, label 7 also. So it will give up to 7. First is single record. Next is 257. Next is 227. You find a difference, right? df dot iloc of 227. df dot loc of 227. Did you find difference, guys? In iloc case, indexing, right? This same 2 as considered as index. So it will take 2 to 6 only. But this loc means it is for labels. This is for positions or indexes. This takes from 2 to 7. So we understand how to select the columns. How to select a column using square bracket. How to select the row using either iloc or loc methods. Now let's work together, try together. So first I want iloc method, loc method. Two options we have. If you see the parameters of first iloc, it takes rows first, columns next. iloc, it looks like a method, guys. Generally, method means we write a parenthesis. Don't confuse on this. Method, we may write parenthesis. But you see, have you written a parenthesis here? It is a method only, but we are not writing as a parenthesis. We are writing a square bracket. iloc, square bracket. First rows, tell about what rows you want. Next, tell about what columns you want. Okay. So, iloc. What rows you want? There are two options to you. You say, I want one row only. First is the row selection, right? So, what do you want? You want a single row? Or you want a specific set of rows? Like I want a 157 like that, or row slicing, commonly row slicing, right? So, I am saying I want 2 to 7. Means because of iloc I am using 2 to 6 will be taken. Rows 2 to 6, fine. Columns, what do you want? Second comma, second is the columns you tell. Columns I want 0 to 3. 0 to 3 means 0 column. 0 column is student ID. 1 column is name. Second column is age. Third column, course. Will it be included? Will it be included? No, that 2 to 7 or 2 to 6, whatever you want. What rows you want? Tell me, Alok. What rows you want? What rows you want? Okay. So for this, what is the output? I'll do this in a different way. Wait. So tell me this query. What is the heading I'd write for this? Selects rows from 2 to 6 and calls columns from 0 to 2. Am I right? You can do a print also. See, 2 to 6. Columns 0, 1, and 2 only. If you are not using a print, so tell me, this command is returning you data frame. Am I right? From the existing data frame DF, you are selecting some particular rows and columns, and it is creating a new data frame, returning as a new data frame. If you want, you can store that in a separate data frame also. df1 equals to something like this. You can print a df1. Got it? If you temporarily we don't want, right? So don't do any assignment. Directly you print. I'm not using print method just to make the look and feel. Otherwise, you can just in real world scenarios we have to call a print always. Got this command? Okay, guys, now tell me this. Select the rows from 2 to 6 only. Columns. Columns. And you are telling the column names, am I right? You are telling, you are not using the column slicing here. You are using the column names. Two columns you are saying name and above column slicing I used 0 to 3. But here I am telling I just want name and course only. Name and course are somewhere here. I am picking particular two columns. So now do you understand how to get the rows and columns? Two commands clear, guys? So I'm showing both with the iloc and loc. First is the iloc here. This is the loc. In iloc also, see, rows same, columns, you have your option. Columns you can say like this also. Columns you can say like this also. Here also if you want only two columns, yes, you pick two columns here. What I did. Okay, this is iloc. Iloc means we can't say columns, guys. Only indexes always, sorry. Loc, this is loc. Yes, we can use. Next, column slicing. So we can use iloc or loc, column slicing. So I want first two columns. Rows, first parameter of iloc is the rows. I'm just writing colon. What it means? I'm writing colon, just colon. What it means? All the rows, very good. I want all the rows, but columns, I'm using slicing 0 to 1, 0 to 2, right? It means 0, 1, 0, 1. Rows all, column slicing I am saying. And same loc also, rows all. This also column slicing guys. Name, colon, course. Column slicing can all, not only with indexing, you can also with the labeling. Name, colon, course. Name to course. Name to course. All will be taken. For example, you go to original data set. We have, this is right. Name, age, course. So name is the index is name 1, age 2, course 3. I want these three guys. Name to course. Tell me in two ways. Tell me in two ways. Here tell me. I want the name to course. What I have to use now? Name to course. What I have to use? Name to course. What I have to use? 1 colon 4 because I want up to 3. Same you can also write as name course. Both gives same thing, right? Name age course. 3, all rows, 7 rows, 8 rows, 0 to 7. This also 3 things. Column slicing is clear. We can also go for a negative indexing. Generally, we won't use that, but yes, when our indexing is there, always you can also go for. -1 gives you the last index, last row. iloc one parameter only I am passing, guys. iloc one parameter only I am passing. One parameter only means it will take for one parameter take for rows only. If you want columns also, then you write comma, then you specify the columns. I am not say writing second parameter for iloc. What happens? It brings only the rows. -3 to second I am not saying. So it -3. -3 means what is the -3 in this? This is -1, -2, -3. -3 to end. -3 to end means course city and fee. We definitely will not use negatives, but yes, have a look at once. So I got only the one row here. This is -3 to. Oh, these are the rows. Sorry, I did wrong calculation, guys, previously. This is -1. Last row -1. This is -2 and this is -3. -3 done means 5, 6, 7. Yes. Next is first iloc, first colon. First colon means all rows. Second, I am saying only -1. -1 means last column. Yes. In arrays, in data structures, we discussed the -1 negative indexing many times, Anik. Negative indexing. You have anything here, indexing anywhere, whatever entry you're taking, indexing 0, 1, 2 means the last always takes as -1. This is -2, -3. Suppose I have a 10 here, 20 here, 30 here. 10 you can call as 0th index, first element, or it is also -3. 20 you can call as a index 1 or -2. 30 you can call as -1 or 2. iloc of -1. What is the meaning of that? What are iloc parameters? What are iloc parameters? Rows and columns, right? So if I say two comma, if you write a one parameter, second parameter, first description is about rows, second description is about columns. If I say iloc of only one parameter, it is all about R, rows. Okay, you are telling -1 means you are asking a specific row whose index is -1. Which is the row index -1? The last row, it will come. Slicing, I am asking the row slicing, -3 to end. So row -3 to end means -3, -2, -1. And here I am telling rows, I want all the rows, comma, second is the column. Column I want -1. So specific column it will take. Or columns also you can do slicing with negative. For example, I want something like this, guys. I will tell my requirement. You tell me the command now. My requirement, you listen here. So I want last 3 rows, guys. 5, 6, 7. Okay. I want last 3 columns. Course city fee. Last 3 rows, last 3 columns. Tell me with negative indexing. What I want? Last 3 rows and last 3 columns. Last 3 rows, -3 to -1 or -3 colon something. Then you see here, you got the last 3 columns, last 3 rows. Exactly. So indexing, slicing, negative, all that clear. Other selections, we won't use this, but just yeah. You tell me what happens because of this. This tell me, I'll write a comment. This command you read and tell me. df.iloc of :::2. Alloc, right. Step 2, it is very good. So what rows it picks, guys? Alternate rows, right? Alternative rows. And all columns, are you writing anything? Are you writing anything, guys? Columns? No columns, right? So all columns. All calls. Next command. What about this? Alternative columns and alternative rows. Columns are second parameter columns. That also I am saying as this. Say this. So first we got all the columns. 6 columns we got it, right? 6 columns we got it. Alternate rows 0, 2, 4, 6. Very good. Next rows same only. Alternate rows. Columns also I am telling alternate. First student ID, then ignore this, then age, then ignore this, then city. Student ID, age, alternate columns. Fine. So clear, guys, this selection, all that clear? Just quick revision of this. So how to select a single column? Selecting columns, you can add df of column name. Multiple columns means df of column name of list. And iloc method based on indexes. So you can specific row number you say, or specific list of rows you say, row slicing you can say. Same using loc method, labels only. Indexes only can be did as specific label, row label, list of row labels, or row label slicing. Then together means you can select iloc or the loc, both takes the two parameters. First represents the rows, second for the columns. So first rows, second for the columns. You can say which column you want, which row you want, a specific or a slice, whatever you want. Slicing columns, yes, you can do this. Column indexes or a column names also you can use in a slicing. Negative indexing also we understand. Step also, if you want, you can increase. You want alternate columns, alternate rows, whatever you want, you can do it. That is selecting based on indexing and labeling. Okay. Yes, we have an access. Whenever your data frame or any uh, array which is a 2D, 3D, 4D, we have a access, rows and columns, right? One x-axis is there, y-axis is there. Always 2D array means two axes are there. So the operations here, generally we are not saying the axis because we are clearly telling about the row wise or column wise. So, but there are use cases where we can specify axis. We'll see that. Axis, already we are doing it without knowing. So row selection is one axis, right? Column selection is another axis. In data frame, special methods are given for a row selection, column selection, whatever. That's what we are not explicitly saying axis 0 or 1. Axis 0 means row wise only. Okay? Okay, guys. Next, go for a df of 0. So df of 0, is it possible? That's the question of Shivsagar. What happens if I use df of 0? Tell me, guys. df of 0, what happens? Quick. First row. Row selection is always with LOC or ILOC. Am I right? You see the headings of the concepts here, guys. First is the A, task A, column selection. In a column selection, DF of, you specify column name or list of column names. Okay. Row selection is second. Row selection you do with iloc. Or row selection you do with loc. If you want to select the rows, you have to use either iloc or iloc. Without iloc and loc, whatever you're selecting, that is only columns, guys. Understand? You can't do this. This is not okay. What is happening internally is, you see the error and tell me what is happening, how the system is checking internally and why it is giving error. Tell me, read the error and tell me how it is thinking internally and why it is giving error. It is considering this column, this 0 as a column name, column label. Do you have a column label 0? Do you have a column label 0? df of age. What happens now? It checks whether any column is there in this data frame whose label is age. Do you have any column with the label? Yes. So it's bringing and showing it to you. Similarly, when you do like this, it is checking only any column is there, any column is there, any table is there, any column is there with the label 0. Not there. So it is giving. Yeah, if you want to change the columns, you can. For example, how to change columns now? Tell me. df dot columns equals to 0, 1, 2, 3, 4. This is unnecessary for you again because column labeling already done automatically. But if you want to reverse it, yes, you can reverse it. Now, df of age, will it work, guys? Error. Can I write df of 0? Do you understand now? Okay. I have to give as 0. Why df of 0 not taking? Because I didn't assign this actually. But data frame changed, right? No, it is not taking that out. Oh, wait. Hmm. So df of 0 is you're getting as 0 column. Understand? So whenever you refer df of something here, you write as a 0, or when you write df of age, how it is treating now, tell me? How it is checking internally? This is the label. There is a label. If label is there, yes, it works. Label is not there, it won't work. So got this point. So I'll keep these points here. Just leave like this. Okay, guys, that's fine. Next, modifying the data frame. So once data frame is created, depending on your requirement, you may do changes on that. You may change the data frame. You can add the columns, you can rename the columns, you can delete the columns, you can add the rows, you can delete the rows, whatever changes you want, you can do. I just taken a small data frame with the 3 columns only, name, age, course, which has 5 records, right? 5 rows are there. Okay, I have a simple data frame with the 5 rows ready. Let's start with the first column. Renaming columns and indexes. Renaming columns and already I told you this, right? Just now I told how to change the column names. If you want, you can change it. There I told all column names, but if you want a specific column names you want to rename, yes. Rename a column, single column. df dot rename method you are calling, and you say columns equals to a dictionary, course existing column. New column I want as my course. One only I am changing. And in place equals to true. What it makes? In place equals to true. If you're not making in place means the current data frame has to be modified. If not, if you're not giving in place equals to true, it won't disturb the current data frame. It will create a new data frame. In that, it will change the column name to my course. I don't want unnecessary new data frame. Current data frame column only, my course column only has changed to my course. Okay, done. Next, you can also rename multiple columns. Columns equals to name to full name. Name I am changing to full name. Age I am changing to years. This many years, like instead of age, years. Again in place two columns I am changing. And rename column indexing. Columns also you can no rename row indexing, not column. Row indexing, guys. Rename df.rename of index equals to see, these are the records, right? What is the row currently, guys? What is the row index? 0. 0 row index. I am changing to row 1. I'm changing to row 1. 1 index of the row, I am changing to row 2. Only these two I am changing. Remaining rows I am not changing intentionally. Again in place. Just run this and see what happened. Initially, I changed only course to my course and display df. At this time, my course is changed to my course. Next again, I changed name to full name, age to years and printed. So name to full name, age to years, course to my course. In these two cases, rows are not changed. Row indexes are still 0, 1, 2, 3, 4 only. But later I renamed the row indexing also. Row indexing also. Name, rename, index equals to, when you say index, this is for row indexing. When you say columns, this is for column labeling. Understand? Columns equals to for renaming the column names, column indexes, column names, index for the rows. So now you see, guys, row 1, row 2, 2, 3. We didn't change these 3. Do you have a index 0 row? 0 row do you have? Do you have a label 0 row? 0 row not there, guys, now. Row 1 not there. 2, 3, 4 is there. Is this clear? Next, adding a new column. This is also one very useful requirement, guys. So we have a data set. Lot data set is there. You want to use some columns and do some maths on this and you want to produce results. Suppose here we don't have any marks column, right? Student marks I'm adding now. DF of marks. Do you have a column? When you refer this, what happens? What is the meaning of DF of marks, guys? In data frame DF, marks column, right? Marks column. Do you have that? No. But I am assigning a value. So 5 values list I am assigning. New column will come and the new column marks, it will give us, this is for a first student, second student, third student, fourth student. And now I am taking another column, df of past. This is, I am not hard coding data. The marks above are there. Greater than, this is for a Boolean indexing, guys. What it produces is df of marks greater than 15 means df of marks. Suppose when I printed df of marks, what will be printed? When I print df of marks, guys, it will print 85, 90, 88, 60, 72. This condition element wise operation. Element wise, it will check as 85 greater than 85. Right? Now 90 greater than 85, 80, 90, this is 88 greater than 85, 60 greater than 85, 72 greater than 85. This guy is the false, this guy is the false. Okay, okay. 2 guys passed, right? So it is going to create a new column in the data frame passed. In that it will set, this is true, this is false, this is false, this is true, true, false, false. We got a new column with the data calculated, computed based on this. See, we added a new column marks with the data taken from outside, and this we calculated. We got in new columns into the data frame. This is most important. We do this actually. Got it? If I say greater than or equals to 85, first guy also 85, right? First guy also true. Yes, yes, Anik, this is the assignment you are doing. You are assigning hard-coded values. You are assigning computed values. What is the result of this? What is the result of this? Result of this is a list of Boolean values, right? I am hard coding the list of integers, list of mark values into the df of marks column, new column. Boolean values I am assigning. Fine. But in this Boolean values, instead of hard coding, I am computing. This expression gives you the Boolean list only. The condition will be verified on every element in this selected df of marks. When I say df of marks, all the values of df data frame marks column will be returned. All the values will compare with Boolean is going to read. Okay. Because your question I understand. This is very important technique. I think you have to keep in mind, guys. Currently, data frame already added, right? See, when I rerun this code, okay, I'll redo this. See, come here. Okay, this is my data frame. Freshly, I'm running this, guys. At this stage, in my data frame, 3 columns, 5 rows. Okay, fine. Here I am renaming just columns and row indexes. Yes. As of now, what is the current status, guys? We have a 3 columns renamed full name, years, my course, and row index is also changed. Now when I say this, as of now, 3 columns are there. When I run this code in data frame, we have full name, years, and my course are there. So when I run this statement, we have a data frame marks we are adding. Okay, added marks. Then we printed. Okay, now I'll run this program. Then when I add past, we're going to add one more column called past. Very important this. See this carefully, guys. I am running this. Yes. See, first here marks there added, right? Then past added. Now, currently in data frame, how many columns are there, guys? 5 columns are there. Full name, years, my course, marks, past, all are there. When I run this cell again, here you are adding a data frame. You are trying to add data frame marks. Okay, already there it is. But this past already there in this current data frame, right? So when you are working project something like this, if something mistake happened for you, you have to go back and rerun all the code to get a clarity. When you do project, you will understand this headache. You understand? Yes, adding a new column is done. Next, modify an existing column. You can change the values also. You can change values. Suppose years are there. I want to add one for every year. This operations, you know, I think now, right? Age is currently years 25, 30, 35, 40, 45 taken. DF of years. What DF of years will return? DF of years will return. Tell me, guys. It is a list only, right? List of 25, 30, 35, 40, 45. This is actually internally numpy array. plus 1, right? NumPy array plus 1, element wise operation. That's what we discussed. We studied NumPy. It will do this 25 plus 1, 30 plus 1, 35 plus 1, 40 plus 1, 45 plus. And also I want to do my course. Course, you see, ML, anyway, ML all capital only, DevOps, D, O capital, remaining small, Java, some small, DL, the capital. I want to make every character in this course as df.course equals to df.course dot str dot upper. All it is going for uppercase. See, age is increased by 1, all the course values increased to upper. Another question is why upper, why str? Can you tell me why I call as str here? There is a reason for that. You can guess that. Very good. What is the type of my course column? Object. Yes. Directly can I call dot upper on the object? No, you can't call that. That's why you are converting this to string. Then your uppercase is a method of a string class only. That's what our object to string. Then on string you're calling an upper method. Done. Modifying existing column values. Yes, like this. This also very each point I have written is useful when you do the projects, guys. We will do that actually. We will use this idea somewhere. Next, you can add a new row. Generally, this we won't do it, but yes, you can do that. Alloc 5. Fifth row I'm adding. Fifth row I'm adding. That fifth row as Kiran 40, Python 95, and generally we will load data from a data set which contains maybe thousands of records and tens of columns. Data we won't add from our machine learning programs. This is majorly for take the data, analyze, run the machine learning algorithms, do analytics, do whatever you want. No, we won't programmatically add the data in practical. But yes, if you want to do, you can do this. Okay. Updating a specific values, guys. I just want to update specific value. Now, can you guess this syntax? I have a two methods. At, at. You can guess it. Update a specific values. We have seen update a specific values. At is taking two parameters. Maybe can you tell what are two parameters of at? You can guess it. What are the two? Two belongs to, what is two belongs to, what is marks here? What is two, what is marks? If you can crack that over. At df dot at of 2 comma marks. Second row, yes, first parameter is the row, guys, the row and column. So second row, row 2 is a label. Label. Second, yes, here, which column? Marks column. Where is the marks column? Second marks column, this one. The heading you see, updating a specific value, one specific value. So this I am changing, this particular student's marks 88, changing, assigning 100. There is by label, right? Next, I at df dot, I at means index. This is based on label. I means based on index of position. I at of, again same, row and 3 comma 1. Tell me this, assigning 50. What is 3? What is 1? Where it will change? 1, column is 1. Column 1 means what, guys? Column 1 means what? Years. Okay, you are changing years. Which is student years? 3. Is this 3 is the index? Yes, you have index 3 here. This will be changed with marks are changed. Why this is not changed? Years. Oh, okay. Here. Fine. Next time I change. Done. Sometimes we do deleting columns also. When you take a data frame, data set, you got a very big CSV file. Okay. Then you in that there are 25 columns are there. Maybe 30 columns are. Sometimes you may have 100 columns also, guys. Some of the columns unnecessary for you. Nothing to analyze on that. Useless columns will be there. Why to keep all those useless columns in the data frame? Because data frame is an object, right? Data frame is a dynamic Python object sitting in the main memory, already having thousands of records. We no need to keep unnecessary columns, which you don't want to analyze at all, or no use with that column. You just drop that. After loading it, you see any useless columns, you drop it. So that if the data frame has 1,000 records, column remove means 1,000 values will go off. That will save memory, right? So you can just currently I'm printing data frame and drop of df.drop columns equals to pass the columns. If you want a one column you want to drop, two columns you want to drop, all the useless columns find a list and pass here and make it in place true, all will be dropped. Passed column I am deleting, guys, here. See, previously passed is there, now passed is dropped. All the values gone. Deleting rows also. If you want to delete the rows, yes, drop. See the difference. Same drop only we are using. Same drop only we are using. Drop index equals to. Index means you are telling about the rows. Index means you are telling about the rows. 2, 3. 2, 3 rows we want to delete. 2, 3 we want to delete. 2, 3. These two has to be deleted. See, 2, 3 gone. Row 1, row 2, 4, 5. These 4 rows only we have. Columns, deleting the rows, deleting the columns. Done. See, these all you are updating data frame. Devayani. In place is most important, guys. If you make in place false, it will create, it won't change your data frame. It will create and return a new data frame to you. That is unnecessary for you. I am asking that my current data frame has to be updated. That's what we have to say always. These updatable operations, deleting rows, always use in place true. Deleting columns in place true. Okay. This assigning values. Values directly it will assign data frame only. And adding a new rows, directly it will assign the new rows. Modify existing column value, existing columns, adding a new columns, right? And column renaming also you need an in place operation. Otherwise, unnecessarily you will get a new data frame. Okay, guys, modifying data frame is clear. What we have done in this modifying data frame, we first learned renaming columns and indexes, columns and rows, right? Now, adding a new column, modifying existing column values, then adding a new row, updating a specific values, deleting columns and deleting rows. Very good. Now come back here, deleting columns, deleting rows coming here. Yes. So this is the case, guys. If I want to delete the first record, Srinivas age 27, ML 85. Tell me command for deleting this, please. Sivsagar asked a question. Now the same question I'm asking for all of you. Tell me command. You try and think. Tell me the full statement, what I have to do. Type the full statement. I want to delete this first record. Tell me. Write down in the chat box quickly. Full command for deleting the first record. Drop the delete the first record. Ram Prasad, the delete command not there, Ram Prasad. The drop command only have to use. First record I want to delete, guys. If you are not answering this, you didn't understand the story I told today. As of now, all answers wrong only. I got only one answer right, two answers right. I got only two answers right. You are using more brain, I think, guys. Tell me the command. Can I use this command? Okay, df.drop, simply index equals to what indexes of the rows you specify. Which one? Do you have a zero index, guys? Neha, where is a zero? Zero not there now. It is already renamed to row 1. No zero, no zero, no zero. This is row 1. You want a row 2 also? Comma, row 2. You want fourth record also? Comma, 4. Dakshinamurthy, you are making the query complex. You just write index equals to list of the index. Simply you write df dot drop of index equals to the list of rows. First row, row of 1, row 1, row 2, comma 4. What do you written above? See, guys, above you written a 2, comma 3 list, simply remaining all same. Now you want a row 1, row 2. This is the 0 not there, 1 not there now. 2 already dropped, 3 already dropped. We have 4. This command. Let's print this. What is the mistake I have done? Okay. The mistake is 2, 3 not there, right? 2, 3 already deleted. Again, I'm running this command. So I'll take this into another cell, guys. This anyway. Okay. Mistake done. So in that case, what you do is just we'll go back to beginning of this code and we'll start running from the beginning. Okay, let's start the entire data frame taken, then rename A, then add a column, modify it, add new row, update a specific values, delete the columns, delete the rows 2, 3. So 2, 3 deleted, row 1, row 2 we have. Next command I am doing as this. See, guys, row 1 deleted, row 2 deleted, 4 deleted. Make this very clear, guys. Clear? Now clear, everybody? We have only one row. So this reset I cannot cover now because we have only one. Okay, let it to do. We have only single record. Okay. What is the row index? 5. Okay, let it be. Just do reset equals to reset index. I'll explain every reset index furthermore. When I do reset, it will come to 0. It means, suppose you do like this. You have a table, a data frame, you deleted some rows and all. Finally, suppose you have rows remaining are 2, 5, 7, 9, something like this. Here for us, as per our operations, only one record pending is 5, right? When I say reset, it starts from beginning as 0. Suppose you 4 records left like this. Assume instead of one record like this, 4 records left. These indexes are in order because I dropped anyway some rows. After dropping the rows, I want to make again the fresh reset indexing. When I call reset indexing on this data frame, it gives you 0, 1, 2, 3. So that gaps and all, it will clear it. Okay? That anyway, I'll show you further. And anyway, shown here, reset indexing resets from indexes. How to add rows already I shown, guys. How to add rows I shown here. Adding a new row. This is only named indexing. See, every row will have by default a 0, 1, 2, 3, right? These two only indexes, we change the label to n. Clear? Hello, clear? We have already studied we named the index instead of 0, 1 previously, I changed it to row 1. Now 0 not there. Row 2, 1 not there. This is still remains as 2, 3, 4, 5 only. You can add anywhere, but you should have the index. You should know the index of that Anik. Anik, if you want to add a question of Anik is you want to add at the end, yes, anywhere you want to add, you bring the index of the last. You find a number of records available. If 10 records are there, you keep that index as 10 only. There is no column index resetting, Vishnu. This is only row index resetting. Index resetting, index is represented as column rows. You see here, drop columns equals to something. Drop index, when we refer index, that always related to the rows. Okay. Generally, we won't go for indexing for the columns. Columns already have labels, right? Columns already have labels. We always prefer to use labels for the columns. So there's no resetting required. Even if you drop the columns, no resetting required. Am I right, guys? Yes or no? We have a columns. Already labels are there. Always we'll prefer to pick this marks. Passed column values, marks column values, my course column values. That is easy or index is easy. For a columns, you want a labeling is easy or indexing is easy. Index means 20 columns are there. Now, if a particular column is, you have to go and count it. Then that which column? Marks column. Whatever the column number it is, label is easy. But a rows wise, rows, label is easy or index is easy? Index. I just shown an example that you can also label the rows To show that, to prove that, yes, rows can be labeled, I given a row 1, row 2. Generally in practice, we won't do this. Rows always 0, 1, 2 indexes will be there. We will prefer always row indexes only. Columns always labels only. But rows can have indexes and labels. Columns can have index and labels. But we prefer labels for the columns, indexes for the rows. Done? Okay, update is done. Modifying data frame, all options completed, guys. Then go transforming, sorting and resetting index. 3 options. These are mainly for rearranging. These 3 I kept in a 1 because of rearranging. Transpose mostly we may not use, but yes, you learn that. So transpose operation. I have a data frame with the 3 columns and 5 rows. Okay. Transposing data frame. It just swaps rows to columns, columns to rows. DF, my current DF, let me to create this. Yes, created 5 rows, 3 columns. Rows to columns means it will reverse it. How to transpose is simply df dot t dot capital T. In NumPy we said it, right? Capital T will give you, internally it will do its operation. Transpose only. You see now, the current data frame is like this, rows and columns. So after swapping rows to columns and columns to rows, we got like this. Your columns here and rows. Either way, fine. You can access like this also. Now columns having, what are the columns, guys? 0 is a column, 1 is a column. Indexing we are using for columns, labeling we are using for rows. How many rows are there? How many rows are there? 3 rows only. 5 columns. Yes, 5 columns are there. Okay. So what I am doing, you see, guys, df dot t, I am assigning to my df. I am assigning to my df means the transposed data frame is assigned to my df, printing my df. This is the output of my df. Later I am printing my original df. Original df is not altered. Remember, the transpose is creating a new data frame. It will not alter the current data frame. Got it? With the transpose done. Sorting. So my current data frame I'm printing, and df dot sort values. I want to sort. Sort values is the method we are using. Parameter by what? By age. Sort values by age, ascending equals to false. Means default is ascending. If you want in descending, make it as. This is my current data frame, guys. Sorting by age. This is age currently Srinivas 40, VS 25, something like this. By sorting by age, ascending means 25 to 45. Descending means 45 age, 45, 25. Simple scenario. You understand this? Syntax, you see, sort values by equals to age, sort values by equals to age. This all you have to practice and remember, guys. When you are going to write an exam or an interview, in interview they may give some data frame and ask, okay, do this. You should have an hands-on. If you give a task, you should type that immediately. Each command you read, write down in the notes if possible. Type. Okay? Ascending, descending, sorting is clear. Even you can sort multiple columns also. Very easy to sort in multiple columns. df dot sort values of by equals to, say, list of values. Here by equals to single value, directly you pass single string. By equals single string when you want to sort by single column. When you want to sort by multiple columns, you say that by equals to list of columns. Okay? List of ascending false. What the first one do, guys? This one. Tell me this. This is by ascending order. 2 columns, course and then age. 2 columns sorting, then ascending. This 2 columns sorting, descending. And this you tell me. I'll write the comments. Tell me this. Sort course by ascending and age by ascending. I think I given a clue on the screen. Third one I want. Yes, yes. So indirectly, guys, here, if I write this here, you see how it works. We are not writing means what we are writing? Ascending true, true means sort course by ascending, sort age by ascending. So default is true, true only. No need to write that. Now course age, course descending and age also descending. Then both give us a false, false. This takes what true, false I am writing. True goes to first column, course ascending true, course by ascending, age by descending. Got this point? But for this, alternate statement is generally we won't do this. I will just comment this for your understanding. I written this. This is the most commonly we write. We know to write like this unnecessarily. Default it goes to ascending true and this both are false. No need to say false, false. Both are false. You say this also I'll comment. Both are say one single false enough. It will apply for both as a false only. Got the point? But internally it is like that. Both like alternation you want to do? Yes. Maybe you want to do quotes by descending, age by ascending, you make it as false, comma true. Explicitly how to specify that. See? So we sorted here. What we sorted guys? First quotes. Courses you see DL first. D, D, J, M, P. Courses ascending, right? Ages also ascending. Then we have courses descending, ages also similar to that. Courses and okay. Next guys. Sort by. Yeah, it will change the record means you should know that algorithm. I'm not going to explain you how that algorithm works. The results you have to cross check means that is out of context. How the sorting happens by two columns, sorting algorithms you should know. There we are, and I'm not going to explain that. You have a slight changes in the output. How it works, you have to understand it. Do a practice of take some algorithm and do that sorting. It happens. Okay. Next is guys, sort by index also. You can sort by index also. What is the meaning of sort by index? Okay, let's do first I have a sort course and age by this. So after sorting, I got this guys. See? So first is the 3 and 0 and 1, 2, 1, 4. So I am asking now sort index only. Sort index only. See what happened, guys? This index is also not order, right? Means we are trying to make this in a original order, right? Suppose in between you sorted or done something. The indexes are not in the order. If you want to make the indexes in order, you just make it as sort by index. Sort index makes this. Sort index in ascending false means again descending. See index is 4, 3. Currently, because of the above sorting happened, because of, no, this is not a reset index frame. I'll tell you reset index next. It is only, see, it is returning a data frame to you. Sort index will return a data frame. It won't change your original data frame. Your DF remains the same. DF remains the same. This sorts and returns, guys, it won't change. See, your original data frame remains the same or not? 30214 is not changing your data frame. I sorted output, I am the sorted result, it is creating a new data frame and returning. That I am printing it. This is creating a new data frame and returning, sorting it. Okay. There are two methods you are seeing here. Sort values. Why sort values? Tell me, guys. Sort values is to sort the values of a given column or columns. Am I right? Sort values is to sort the values of given columns. Column wise sorting, sort values. Sort index, row wise sorting. Yes, Anik, you are right. Okay, guys. Next, reset index is important. Sometimes after filtering the rows or dropping the rows, index is not continuous. Already we observed that. So we can reset it. We can reset it. Suppose I have data frame, current above data frame I displayed. From this data frame, was above data frame we have, guys, this one, right? This one, 302, because I sorted the data frame, 30214 is there, current my data frame. From that I am dropping in drop index of 1 comma 3 in place 2. Tell me what happens. Tell me what happens. Drop index equals to 1 3. Drop index equals to 1 3. What happens? Drop index equals to 1 3, guys. What happens? Only 1 3 has to be deleted, right? See, it means, will it delete the high record 3, 1 record was, or as per this, 1 means this, 3 means hello. What do you think? Which names will be deleted? Tell me the names as an output. Index 1 will be dropped, means VAS has to be dropped, right? Index 3 has to be dropped. 3 means high has to be dropped. Very good. That is important. So after that, before reset, I am printing it. You see the difference. Now when I say reset, it will order it. Let's see the output of this. So my previous data set is 302 like this. See, 3 gone, 1 gone. Now what is the order of indexes, guys? 0 2 4 are there. I don't want this like this. So I want reset. Just make it freshly order from 0 in a sequential order. Reset is doing this. After reset, you got like this. Do you understand resetting? That's about updating data frame also we completed, guys. So we are done module 2 successfully. Okay. That's it, guys. Do practice all of this. We will continue the next module. Selection we'll do in the next session. This is all about RDNA multiple queries. Okay, and you will see this in the next session.